Hello everybody, we're going to talk about proofs again today. Today we are going to talk about filling in proofs and filling in the blanks. So you can see we've got some blanks here to fill in. I'm going to read the given statement up here that AC and DF bisect each other at point E. And so we need to look at what we're trying to prove. We're trying to prove that triangle DEA here, this triangle that I've marked, and FEC need to be congruent to each other. E and C up here. So we need those guys to be congruent to each other, so this other part over here with point B is really not necessary. So we're going to start with our given statement here. And so we're going to say that AC bisects DF. And we're going to say that DF bisects AC. That was given to us. So now we're going to go in and get the pieces that we need to prove congruent to each other. And so we will start with what was given to us up above here, and the fact that AC bisects DF. Then I'm going to say that DE is congruent to EF by definition of bisector, definition of segment bisector. So I will mark those congruent up here. The next statement that we're going to use is we're going to use our bisector here, and that DF bisects AC. So we know that AC is, AE, we'll make it an E, AE is congruent to EC. And so if I mark those up here, same reason as it was for 3, definition of segment bisector. And then, so now, right now, we have a side and a side. We need one other piece of information that we can get from this. And if you remember from that worksheet that we did, we had that we could use vertical angles by looking at the drawing. And so we can see that this angle here is congruent to that angle there. So angle DEA is going to be congruent to angle CEF. That would be an angle over here, and we can say that by vertical angles. And so why are these triangles congruent? Well, if you look, we've got a side, an angle, and a side, an angle, and a side. So our reason why these guys are congruent is SAS. All right, we have one more proof that we need to talk about. We got this guy right here. So we are going to write down our given statement, and this one didn't break it up as much as the last one did. So we're going to say that SR is perpendicular to RT, and TU is perpendicular to US. There's one given statement. And the other given statement, the reason why I'm setting it aside on its own is that it's going to be something that's going to help me prove this. Because remember, we're pretty much always looking for angles and sides as we do this. And so if I have a pair of angles given to me or a pair of sides given to me in the given statement, that's going to be kind of important. So angle STR is congruent to angle TSU. So was STR, this angle right here, is congruent to that angle right there. We should probably look at what we're trying to prove. We're trying to prove triangle TRS, so this triangle, T to R to S, that triangle, congruent to SUT, so it would be SU and T. So you can see we're basically talking about these two triangles that we have kind of overlapping, and maybe it would be helpful to draw them separately and draw them the way they're oriented. One triangle is SUT, and the other triangle is, what is it? It is TRS. Oops, I think I did that one backwards. Oh well, it is backwards, but sorry about that. But we have that piece, those pieces of information. So now that we have that, we have those angles congruent to each other. Well, let's talk about the perpendicular, the other stuff given to us. So we're going to have to say that they told us that that SR and RT, so SR and RT are perpendicular. So that means we're going to get a right angle in there. They also told us that SU, or TU and SU, are also meet at a right angle, so we're going to have a right angle in there as well. So in this case, we'll be able to say that we have right angles, and so we'll be able to say that angle TRS is a right angle, and angle SUT is a right angle. And this is by definition of perpendicular. Now that we have that these guys are both right angles, well, we can go down here and say that angle TRS and angle SUT are congruent to one another by all right angles are congruent. And so that leaves us with two angles, angle here, angle there. So if I mark them up here, we have angle STU, which is this guy right here, and that guy right there, TSR. We also know that these guys are right angles. And so if we want, we can then say that we have a reflexive side of ST. So ST is congruent to ST by the reflexive property. And with that, then that gives us a side, and you will notice that in our two drawings here, that we have two angles and the side not between the two angles. So my reasoning why these two triangles are congruent is angle, angle, side. So this concludes our proofs for today. I will talk to you guys soon. Bye.